So hi, I'm Lauri. Here I'm in sort of hybrid professional / hobby capacity. So I'm still a board member at the Hackerspace that we started 5 years ago. We're going to be turning 5 years in October. And at the same time, I'm sort of presenting something from my daily work at Outfunnel. So I spent some time at Google, came back to Estonia, and now I'm working at the startup called Outfunnel, where we basically, at the moment, we're syncing emails between different systems, but there's more interesting work coming up soon. So, just to keep the talk a bit more interesting, I don't want to talk about some boring web applications, like with whatever payment systems and stuff like that. So. The stuff that I'm going to be focusing in this talk is mostly about the Hackerspace. So the k-space is a Hackerspace that grew out of the Estonian Robotics Club, the Robotics Club of Estonian IT College, and we've got. Let me show quickly. There's the floor map is here, which I guess explains it a bit better. So we've got like almost 400 square meters of attic space in the Kubernetes Maja in the TalTech campus. Okay, let's go back. Let me show you. Oh, so yeah, board member at k-space and senior infrastructure engineer at Outfunnel. And I wanted to show the floor plan for the space. So. Almost 400 square meters of space in the Kubernetes Maja attic, and I suppose if you've been to Berlin, Berlin has like tens of different hackerspaces. I wanted to bring. I was a student in Berlin, so I wanted to bring like different elements of different hackerspaces back to Estonia, and that was one of the reasons why I wanted to have the hackerspace. But something that's kind of unique is that we also have server room there. And lots of the people that are the members of the hackerspace, they have interest in hosting servers. A lot of the people work either in a company that deals with server hosting, or some people, like including me, has had a physical server for now more than 10 years, in some sort of hosting, and now it has found a home at the hackerspace as well. And one of the projects that I wanted to highlight in this talk is this camera system, and which I'm going to talk about in a minute. So a little bit about the hardware stack that we have there. So most of it's hoarded from different Estonian companies, some of which don't want to be named, of course, but. The level of the hardware that we have at the moment is this. We've got, DDR4 ECC memory, costs a fortune on eBay. So I think we have like thousands of euros of worth equipment that was basically otherwise would have gone to trash, basically. So we scavenged that and built an interesting setup for playing around. And if you look around on Reddit, there is this home lab subreddit. There's also self-hosting subreddits. So you can see what kind of stuff people post there. So ours is more epic than whatever you can find there. Most of the home labs are just half of a rack of few disk storage systems and few servers, but we've got like 5 racks. So. How does this all relate to Python and software engineering? So before I went to Google, I was kind of frustrated with managing the infrastructure of the hackerspace. There was a lot of manual work. You would allocate the whole Thursday evening just to do get upgrades, maybe just for one service, and then it would break. You would have to roll back, do all sorts of crazy stuff. And I wanted to, when I came back from Google, I wanted to sort of figure out a way for myself, first of all, how to run the hackerspace infrastructure in a way that causes me less headache. And considering that the hardware is old, the hardware death is lurking around the corner all the time, so expecting that a server will die, it's something that you should be ready for all the time, not that we have a contract with whatever hardware vendor, and they will replace the hard disk in 24 hours. So that wasn't an option for us. So I needed to figure out the ways to make the systems more resilient, to make them easier to upgrade, etc. And in many ways, it was very similar to what Google does internally. Only problem, and the reason why I left Google, was that all of the tooling that they use is Google-specific. They don't have Kubernetes, they have Borg. They don't have Prometheus, they have Borgmon, etc., etc. And I was happy to see that a lot of this work has sort of leaked out from Google, and Kubernetes is basically making the same thing possible outside Google as well. And I think halfway at the Google employment, I started to learn Docker. I had pretty much ignored Docker up to then. And then when I had chewed through Docker, I started chewing on Kubernetes. And for the cameras, basically, the problem statement would be this. I have a bunch of old servers. I want to self-host everything. I can do programming. So that's in many of the cases when you want to host stuff is that, I don't want to do programming. I want to just buy boxes of products and install them. But I was willing to make a relaxed condition there that I can do programming as well. And previously, we used to run the program called Motion. It's just, I think it's the C program that monitors cameras and does the motion detect for the cameras. But the problem with that piece of software was that it was designed for only one machine. So at best, it would scale across multiple cores, but there was no way to make it highly available, to have a failover, etc. So basically, I had a couple of years when all of this was brewing in my head, and I was thinking how to implement this. And this is the architecture that I came up with eventually. It's probably not perfect, but it's just this is just one of the current iteration, let's say. So as I said, we have a bunch of webcams there. Some webcams are for monitoring devices like the server room itself. We've got also a 3D printer. This may be a good moment to show. So this is one of the views from the space. So there are something is crash looping here, of course. So that's why it went green. But we've got 3D printers, workshop camera to see if somebody has maybe cut off their legs, head or something. We've got saw benches there, so there's dangerous equipment there. And some cameras are also for the mailman. So if there's parcel arriving, you can check that there's a mailman behind the door, and you can remotely open the door as well. So I'm not going to talk about the door system, but basically we have our own homebrew door system as well, so you can remotely open the doors. And I think the heritage from the robotics club was that we have a couple of those social cameras, which are just pointing at some, let's say, public areas, just to see if somebody's there. If you want to go and socialize, you can check if somebody's at the place, so you can, go there instead of asking in the chat. Or maybe sometimes people are already tinkering; they're not maybe even observing the chat, but then you can visually check if somebody's there. So, yeah. And this is the architecture that I came up with. The boxes also represent how many replicas of each component are running. So the blue boxes are, most of the blue boxes are written in Python. They tolerate running on multiple hosts at the same time. For the webcams, there's actually an opportunity to run multiple replicas per camera. So if one of the servers dies, you can be sure that at least the other server keeps processing these frames, and you do not actually have a loss. So we just had an interesting discussion with one guy here that losing, what was it? A few minutes of video footage would cost order of magnitude of 5 digits as a fine if you do not deliver, if an item gets stolen during that time slot when your service is not available. So at least for myself, I have reached the point where I've started to see high availability as a standard feature of a software. So if your software doesn't support, for instance, what is it? Rollover update, meaning that there would be a moment where two possibly even different versions of the software are running simultaneously, then I would say this is just a bad design for the component itself. So I've come to see that high availability is not an enterprise feature. That's maybe the phrase that I would use. So yeah, the camera motion detect part was written from scratch in Python. It pulls the stream from the webcam. It performs the motion detection, writes the events to MongoDB, and uploads the JPEG images to the Minio. Minio is a self-hosted S3 service, let's say. And the tiled image that I showed you, this is stitched by this camera tiler. It just uses the in-cluster streams to stitch together a picture of multiple cameras. And the log viewer components, these are actually Node.js applications. These are to stream the events to the browser. I'm going to show it in a moment as well. So this is how the architecture of the application looks like. Behind the scenes, of course, we've got Prometheus, Alert Manager, Greylog, FluentBit, bunch of infrastructure tooling, which is taking care of logging, monitoring, alerting, etc. And also Grafana for debugging the application and visualizing different metrics. And one of the most interesting bits, for me at least, recently, is the camera operator. So operator pattern in Kubernetes is a way to write a piece of software that manages other pieces of software inside the Kubernetes cluster. So just to illustrate the point, so this is how the, let's say, configuration for the application looks like. The camera operator reads this. This is called custom resource definition in Kubernetes context. And then it will create the containers, or in Kubernetes jargon, deployments and services and other necessary objects to get the components running on the hardware. And when I reached this point, I felt really great because it seemed that I had removed immense amount of complexity from the program itself. Like my motion detection component doesn't have to deal with multiple cameras anymore. The camera motion detect component deals with only one camera. All of the whole concept of multiple cameras is dealt by the camera operator itself. And the camera tiler actually discovers all of the camera motion detect streams from the Kubernetes cluster itself. So the camera tiler component itself is also quite dumb, and it just auto-discovers everything from the Kubernetes cluster itself. So, but now comes the hard part. In order to run all of this, you need quite a bit of infrastructure in place. So if you're a hipster startup, you can fall back, or let's say not fall back, but make use of the AWS services. So just to make everything more human readable, I've put in the left-hand column the stuff that AWS offers. And in the self-hosted option column, I put the, let's say, alternative technology that I used in a self-hosted environment. So maybe we can just quickly go through the list. Proxmox does the virtualization layer for me. Even if you use Kubernetes, I would say your smallest unit will still be a virtual machine. You need something to create virtual machines in, and we use Proxmox for that. I used vanilla Kube ADM to provision the nodes. In AWS, you have, of course, EKS. They charge you, I calculated, $72 a month just to run control plane, to run the applications, which, of course, I'm not paying, but I pay in electricity. For many applications, especially for legacy applications, you would need block storage. So in AWS, you have EBS. We run Longhorn. And we also run Traffic. Traffic acts as a reverse proxy, so if you have used Nginx or HAProxy, that takes care of that. We initially used the original Docker registry, but the problem with the Docker registry is throttling, so you will easily bump into, like the more you add nodes into the cluster, each node will do a pull request to the Docker hub, and you will easily reach the limit which is offered for free. So a good option is to run Harbor yourself, and Harbor actually has a caching mechanism, so you can proxy all of the Docker Hub requests through Harbor, and it actually bypasses, it will get like cached by the Harbor. Plus, you can host your own images in Harbor as well. Then my favorite database at the moment is Mongo. Mongo has this nice watch functionality. And everybody talks about S3, but they do not understand that there is a S3 which refers to the API that is, let's say, a key value store protocol. And the other aspect of S3 is a product offered by AWS. So Minio replicates the S3 APIs, and you can run it on your own infra. So you get something that is equivalent with AWS's S3, except, of course, the multi-continent replication and whatever, in which case you would need to set up replicas yourself. In a professional setting, I used GitHub OAuth for authentication for everything, basically. So when you want to access Kubernetes cluster, when you want to access whatever our internal web services, I used GitHub. But in the Hackespace setting, we still have Active Directory. We actually run Samba, which is compatible with Active Directory. And we have Active Directory because there's still some weird applications that want to use LDAP protocol, but LDAP protocol is like, ancient. Nowadays, I would say use OpenID Connect where possible. So in a professional setting, I use Dex. Dex can be used to proxy OpenID credentials and do some filtering that, a certain group of people have access to a service. And of course, for source code hosting, I think in a professional setting, I would still use GitHub, but in a self-hosted setting, I would use Gitea. I really like using Gitea. GitHub Actions is still good for building images, but GitHub Actions has a bunch of interesting limitations. And if you want to self-host CI/CD, I would highly recommend Drone. I really like using Drone. And of course, then you have the boring stuff like DNS and overlay network. So this is the listing of the technologies that we are using in the Hackespace. This is a middle column. And it was kind of an interesting journey to get all of these technologies working together. Let's say, software development process, how it looks like. But this is, again, I would say this is rather a DevOps workflow. This is how it looks like at the Hackespace at the moment. Whenever somebody either writes software or changes infrastructure configuration, everything is checked into a Git repo, regardless of whether it's a software or a configuration. In case of software, it gets built by Drone, pushed to the harbor, and then a Kubernetes cluster will pull it from the harbor and run it. If it's a configuration repo, like we have for the Kubernetes manifests, this is actually applied by Argo CD. I really like using Argo. Argo nicely visualizes all the differences. So it basically runs the diff between what is described in the Git repo and what is actually deployed. So our camera application looks something like this. And it shows that it's out of sync, so there's probably some difference that I have applied manually. And this is a good way to make sure that there is no discrepancies between what is described in a Git repo and what is actually running in the cluster. So one of the things that I found really annoying previously was that sysadmins, including myself, made arbitrary changes in whatever VMs, and those changes were actually never recorded anywhere or even documented. And I really like the fact that with Kubernetes, it's very clear that whatever is described is deployed, and there is no room for error there, really. So, and now I guess we get to the point where you're asking, like, okay, I'm a software engineer. Why should I even care? So even if you have like a dedicated guy in the team who deals with the whole Kubernetes cluster stuff, you would want to make their life a bit easier. So I've sort of collected like some of the key points into the next following slides. If you need to load configuration for your application, can be Python, Node.js, whatever. These are sourced in Kubernetes called configuration maps and secrets. It's basically, again, a key value store. And the way they get exported to the application is either through environment variables or they get mounted in a directory. So if your whatever component is small enough, like the motion detection piece, you would just supply the camera address through an environment variable, and that should be it. If you have more complex setup, then yes, use YAML files. Somebody said previously that they don't like YAML files. I also do not like YAML syntax very much, but YAML is the language that is used for all of the Kubernetes manifests. So if your application configuration uses YAML as well, it sort of fits in the picture. One of the annoying patterns that I've seen is that some of the configuration is placed in a database. So, and what happens then is that this configuration causes the application to crash. And then you cannot fix it either. So one of the recommendations I would have here is that make sure that you can fix the application by changing the input configuration, not having to go through some database administration tool into the database to fix the configuration which sits inside the database. So last one was, I think it was Greylog, which was doing that. I found it really annoying. And yes, that's where you would draw the border if you don't want to know anything about Kubernetes. But if you would want to know more and want to actually integrate application better with the Kubernetes, then Python has a first-class support for Kubernetes API. And what I like the most, actually, is that there's this watch functionality. You can watch for changes in the Kubernetes cluster, and this would, for example, facilitate secret rollover. So let's say you need to rotate secrets. You would just, let's say, reset all the secrets in the Kubernetes cluster. The applications would automatically pick up this change without having to restart the application. So these are like some of the benefits if you would want to like go all the way in with Kubernetes in your application. Then one of the sort of philosophical questions I had was when I started with the camera application as well, like where do you draw the borders between the different components? And whenever before also I heard people talking about microservices, that they're very sexy and whatnot, my question was like, how do you partition the application so it actually makes sense? So yeah, one of the phrases that actually came up here is that I think microservices in a way, it's very similar to the Unix philosophy, do one thing and do it well. So the anti-pattern here is that where you're hoarding features. So for instance, what I've noticed in many applications is that they try to integrate multi-factor authentication. And then basically what happens there is that, like for instance, there's a wiki, we run wiki.js. Wiki.js is a very nice wiki software. But it's the same pattern there. The multi-factor authentication is integrated to the application. And you see that the developer is increasingly spending time developing these features. But this is actually not your core business. You're supposed to be developing wiki, not a multi-factor authentication program. So in this particular case, what the application developer should do, in my opinion, is that provide OpenID Connect authentication mechanism and do not care about multi-factor. Multi-factor should be dealt by the OpenID Connect provider, not the client application itself. So this is one of the points that I arrived at. And of course, there's the failure domain. So machine dies, process hangs, process gets killed. There's so many things in that category. But one of the things which is very often overlooked is that if you do not write your application to be highly available, even a simple configuration reload or restart can leave a gap in your SLA, so you might be unable to meet the SLA that you're promising to your customers. And let's say during that restart window, it turns out that, oh, this configuration has an error. We cannot parse the new configuration. Then the application stays down, and this window can extend even further. So with Kubernetes, usually the way it works is that you would have a deployment of one or more applications. And when you reload the configuration, a new instance of the program is started. And before any traffic is routed to that new instance, health checks are performed, and the new version with the new configuration needs to go green before actually any traffic hits the new instance. So this way we can actually serve we can improve the SLA for the service, and we don't leave these stupid gaps in the service availability. Yeah, okay. The other aspect is scaling. So, for instance, in the cameras application here, I think there's multiple aspects here. Let's say if there's many people who want to look at the tiled images of the camera, then I can just spawn additional replicas of the camera tiler application. If I want to ensure, let's say, higher SLA for a server room, then I can increase the replica count for the camera that is observing the server room only. So these things become actually quite trivial to improve the SLA again. And one of the things that I noticed as well is that I really like Python. I think Python gives me the opportunity to really quickly iterate through a prototype. But in some cases, you might want to rewrite a portion of your application in a different language. So that's where the Go and Rust come into picture. And if you have actually structured your application in a way that these performance-sensitive parts are easily separatable, you can do like a quick rewrite for just one of the components. And the other thing that I noticed as well is that I recently started writing a lot of async code. So I use Sanic a lot. I really like Sanic framework. I think Sanic framework really nicely fits into the whole Kubernetes picture. And even if I write like most of the application using async code, I can still, for whatever reason, I actually had a case where I needed to use some sort of esoteric functionality from Python. I could just have this URL handler written in a different language or in a different programming paradigm. So I guess, again, I don't have really good answers how to partition the application from microservices point of view, but these are some of the thoughts that at least have helped me and which I have used myself. And last week I had a nice opportunity to resync a relatively large MongoDB database. So I discovered that MongoDB database it took almost 20 hours to synchronize, after which it concluded that it had still fallen out from the cluster because it was unable to replay the op log from the primary. So after having a bunch of discussions with different people, I concluded that microservice not only consists of the application itself, but also the database. And it used to be the case that persistent workloads in Kubernetes were kind of esoteric thing that you don't want to do that. But if you want to, you can run. And I'm saying that it's perfectly fine to run a database inside the Kubernetes cluster, regardless of is it on AWS or is it on self-hosted infra. And the simple reasoning is that if you keep your database size to the order of magnitude of tens of gigabytes, resynchronizing the replicas the time duration gets really short. It's more easier and more manageable to make backups because the backups take less time, et cetera, et cetera. So basically, the microservice, what I'm saying here is that the database is a key part of a microservice, and this also extends now to the whole microservice boundaries concept as well, that you don't want to have cross-use of databases between the microservices, so you have clean-cut borders between different microservices, which means also that the databases are not used across microservices directly as well. Yeah, and in the Hackaspace infra, I used the MySQL operator and MongoDB operator recently. Very easily creates 3 replicas that are replicated across 3 different machines. And even if you're using AWS, if you use the RDS offering from AWS, we have this nice project called Crossplane.io. This basically enables you to order resources from AWS So you declare in your Kubernetes cluster that I need a database, and then it will figure out how to get it, and you get the secrets injected to your application, basically. Yeah, so this is again something maybe for developers. There are three key aspects to observability: logging, monitoring, tracing. Tracing comes into the picture, especially when it comes to microservices. You want to be able to observe how is the API call going through different microservice layers, how much time does it take. And yeah, I mean, like, just read Prometheus manual. Monitoring is like very well described in Prometheus manual and their blog posts. You know, use C units, do not use milliseconds, etc., etc. But in many cases, it just takes time for devs to pick it up and actually register that, okay, I should do this because this is like the standard way of doing things. And I guess just from the DevOps side, you need to have some patience for that. Yeah. So I guess this is me after, what is it, 15 years? So when I was a kid, I used to think that, you know, I will do my coding. That's the best part of, you know, the whole IT work. And then, you know, then it gets deployed and that's it. And then I can continue writing more code. And on the right-hand side, this is the way I see things now, that coding itself actually, I think is less than a quarter of the whole effort put into whatever software engineering project. You should have at least, again, I'm not a TTD guy, but you should have some sort of testing in place, especially if you're, let's say, parsing bank transactions. I mean, bank transactions have a fixed format. Just write a test that your parsing code actually correctly reads it. So no need to go like into extreme, maybe with unit testing, but for reproducible stuff like that. The other aspect that I highly value now is that software should be written with high availability and scaling in mind, which means that, for instance, you don't use in-memory sessions, that you would use Redis for sessions and stuff like that. I also come to value more linting, and the previous presentation about integration tests, that as well. Very important. I've seen projects where they put effort into mocking LDAP server, of course incorrectly, whereas they could have just started Samba inside the integration test, make sure that it works with you know, widely used compatible component instead of like mocking the interface correctly. And maybe I would say the even most important aspect is delivery of software. I've come to the point in life that if I would need to deliver software to somebody, if I'm unable to do it in the format of a Docker image, then I'm not going to do it. Because over the years, I've been in different projects. I've seen the life without Docker images, where you would have to, you know, go there, figure out, okay, this is running Ubuntu 16.4. Okay, so this OS library is outdated. I need to first actually update the host operating system before I can actually update the application itself. So, you know, this is madness. And I feel like I've spent more than half of my IT-related work on tracking dependencies like that. So Docker images at least fix this issue. And I'm never going to ship any piece of software which is not going to be in Docker image format. And the remaining two big chunks is metrics and alerting. Before any kind of refactoring even, I would say that metrics and alerts have to be in place. You must have correctly described what is the normal behavior of a component. You know, put some metrics in place for success signals, errors, and by alerting, I mean something that gives you like a Slack notification, not that something that you have to go look inside Grafana. So building beautiful Grafana dashboards is awesome, but if it breaks, it should wake you up, not that you have to go look inside some dashboard. So most of the stuff I think I have now explained. This is maybe like a distilled version for the Python application developers. So Kubernetes has first-class support for Kubernetes. Python has support for Kubernetes API. Same goes for Prometheus metrics. Use the official Prometheus library to export the metrics. But one of the revelations that I had with Kubernetes was that all of this mumbling about global interpreter lock and that we cannot have proper multi-threading in Python, this has more or less become irrelevant to me because these threading issues really are supposed to be handled on the level of the orchestrator, which is the Kubernetes work. And basically, in the Kubernetes world, ideal program consists of one process that does no threading, no forking, no multiprocessing, nothing like that. And the reasoning is very simple. You want to scrape, the Prometheus wants to scrape every process directly. So the best layout for Prometheus is that every Python worker, could it be whatever, Django worker or Sanic worker or whatever it is, runs as a different pod. You can scrape the metrics from that pod, and Prometheus is the one that pulls them all together. And if you need more workers, you increase the replica count in a Kubernetes manifest, not inside whatever supervisor D or green unicorn or whatever you're using in the Python world. So my recommendation here is that run your Python application with green unicorn with no threading and just single process, and handle the multiple instances at the Kubernetes level. Yeah, Async.io fits nicely in the Kubernetes world, and I really enjoyed using Sanic framework. And I've had like some bunch of interesting discussions when it comes to memory management. There is no intelligence in memory management in general. Usually the way memory management works is that application requests memory, and basically it gets the memory or it gets basically killed by the OS. Yeah, also virtual enums I don't see important anymore. And yeah, if you want to go all in, there's a bunch of interesting constructs in the Kubernetes API, which you can use directly from Python. I think we're running out of time, so I'm just going to leave the keywords here, which you're going to check out later yourself. And I guess the key takeaways for developers is that export actionable metrics, export the health check endpoint, probably get familiar with Prometheus. There's no way to avoid Prometheus when it comes to Kubernetes applications in general. And prioritize alerting rules over beautiful dashboards, something that is sort of a contract between the DevOps team and the devs. And yeah, at least from the DevOps side, I have never, again, manually edited Nginx configuration. I have never edited DNS entries, manually provisioned database, have a TLS certificate expire, and also with Kubernetes, I'm not doing SSH to a machine anymore. And there are no dangling uncommitted changes left on the machine, so it has at least drastically simplified my life. And one of the philosophical questions or philosophical points that I arrived is that why am I spending time learning technologies that are inherently limited to one machine? So maybe that's sort of a Google brainwashing that I had at Google, but at least since then, my philosophy has been that whatever I'm learning, I want this technology to be scalable. If it's limited by one physical machine, then it's no-go for me. Yeah. So yeah, I released, like before the talk, I released the Kubernetes manifests that we have worked on for more than almost 2 years now. There's a bunch of people who have helped out with this in the audience as well. There's Song, thank you very much for helping out with working on the manifests. I think Marco has helped out a bit as well, at least, and Oleksiy is somewhere here as well. So there's a bunch of people who have helped out with this. I put all the names in the contributors file there. And the motion detection software that I have written is also on this Git repo. And to finish up this, I'm inviting you all to visit the Hackerspace next Thursday. We're going to have a chaos ref 6 o'clock next Thursday. And I guess that's it. Yeah. Any questions?
Yeah, we have some questions here. First, thank you for the presentation. Very, very thorough. Right, so we don't have much time, so let's try to do short answers if we can. This is a time case, 2 years for this, but how long would it take for a skilled software engineer to start self-hosting a simple cluster? Like, ballpark, some numbers.
So we've built the Hackerspace for 5 years. But,
with a team of how many? So
I'm not sure. Like, there's like people helped out with different aspects. So like Song helped to write Prometheus manifests for all of the legacy applications. Like, we're also monitoring OOPSes with Prometheus, which has nothing to do with Kubernetes really. But if we have to do, let's try to get the bodies. If someone wants basic service, that's let me give you some numbers. Yeah. I would say that I used about 1 year evenings to understand Docker and do like all sorts of weird shit with Docker. And then it took another year to get the Kubernetes cluster running. And now probably I'm on the 3rd year of understanding how do you run all the complex stuff, like replicate the databases, make everything actually highly available. So yeah, I would say it takes years.
It takes years. Very good turnaround time there, but it's very, very powerful stuff, clearly.
So one of the thoughts maybe here is that I've at least in a professional setting I've tried to cover my back in many ways. So building the Hackerspace cluster where you've seen all sorts of weird shit makes your life easier when you're running your production stuff in AWS, because like all of these memory allocation issues that we had. I knew these because I had done something esoteric in the Hackerspace infra.
Yes. Okay, I think this question might be from our next speaker, I'm not sure. But this seems a bit complicated and maybe fragile. What is the bus factor on the project? Do you know what that means or no?
Yes, the bus factor has been, factor has been very important for the Hackerspace in general.
If people don't know, the bus factor is if you're hit by a bus tomorrow, how dead is the project?
Yeah. So that is an ongoing effort, of course. I want to replicate
your
myself.
Knowledge.
So I would say, well, actually, when I was at Google, I was more than a year away, and the Hackerspace didn't collapse. So I think it says something about the Hackerspace at least. But yeah, it's an ongoing effort to make sure that you do not contain knowledge that is only specific to you, and you should make yourself redundant as well. So I would say like the whole high availability extends even to real life in that sense that you want to make yourself highly available as well, or at least redundant.
Yes. All right. Thank you very much.